Hey guys, in this tutorial we're going to look at how to create this interesting sort of fluctuating, tapering walkway sort of thing. Alright, cool. So we'll get rid of that and we'll open a new document. So we're going to start for this with an arc, and specifically I'm just going to use the standard arc, which asks for a base plane, a radius, and an angle. So my angle is going to be created by a function, and this function is going to be, it's going to take two parameters. It's going to take a number of segments, if you will. So I'll set this to a maximum of 10, and that'll be my y. And then I'll create another slider which is going to be a sort of a domain. Okay, and so my expression is going to be 2 times pi times x over y. And so what this is going to give me, yes, I'm also going to create my arc in the xz plane. And I'll also need to create a radius value for that. Okay, so what this is going to give me is basically control over how much of a segment I want for my arc. So if I set variable y to 3, that'll divide this arc into 3 parts. And then this slider will let me select a maximum of 1/3 of the entire circle. If I were to set this to 0.5, it would give me 1/6 of the circle. If I were to set this to 4 divisions, this would be 4 over a half, which is 8. So this would be 1/8 of a circle. And this would be 1/4 of a circle. Yeah, so it's just a nice way to select a certain amount of the circle. Alright, now what we're going to do is we're going to create an array of these. And so in order to do that, I'm going to use a construct point. And I'm going to use a series. So I'm going to plug my series into the y. And I'm going to make a copy of this slider, and I'm going to set this to a maximum value of maybe 30. And then I'm going to create a count, and this count can be reasonably high. I'll set it to a maximum of 100, but for testing purposes we'll keep it at 20. Alright. So these are going to be our array of arcs. In fact, I'll set this to 50. Okay. And so now we're going to take all of these arcs and we're going to rotate them. Oops, wrong rotate component. I want this one. So the geometry we want to rotate is these arcs, and we want to rotate them on each of these planes, and we want to rotate them a certain angle. And so that angle is going to be defined by a range component, and the step size is going to be defined by this variable here. So this will give me 5 values. I only want to do 4 rotations, so I'm going to use a cull index, and I'm going to set the index to -1 to cull out my last item in that list, and that'll be my angle. And so it's not quite matching up right at the moment because we've got 20 values coming in here and 4 values coming in here. So what I'm going to do is I'm going to graft my my plane. And so when I graph the plane, okay, it's still not giving me a proper result because my domain is set incorrectly. So this domain, I'm not going to be changing at any point, so I'm not going to bother making a slider. It's going to be 2 times pi. Okay, there we go. So now we're getting our full circle of rotation. As we change this, we're getting our sub-selection, and I'm going to set it back to 3 for now. What I'm also going to add in here is a plane rotation. And and I'm going to do that based on another range component, and my number of steps is going to come from the number I plugged into my series, and it's going to be x minus 1, because the range component is always going to give us the number of steps plus 1. So that goes in there, and also I'm gonna do this graph after I do my plane rotation. Okay, so that I'll take all of those, plug those in there. The way I did that was I held Control Shift and then dragged everything into here, and then I'll plug my plane back into the XZ. Okay, so my domain is set. Everything is looking good. Alright, cool. So the next part of this, we're going to take the endpoints of these curves, and what we want to do is we want to sort of find the middle, the midpoint in between this point and this point here. So the way we're going to do that is with an average component. But if we just plug the start and end into here, it's going to give us a point right at the center, because what it's doing is it's taking all 3 starts and all 3 ends. So we're going to start firstly by grafting this input here, and then, okay, so now it's slightly better, but now what it's doing is, because this point on here matches up to the endpoint of the other part of the curve, so it's going to give us a point over here. So what we need to do is we need to find a way to sort of shift the values in this list. And luckily we've got a component called shift list. And so I'm just going to grab a slider and I'm going to set it to, you know what, just for showing you, I'll set it to -3 and 3, and we'll make it an integer slider. And so we'll plug that in, and then we'll disconnect the end from here, and I'm going to add 2 graphed trees as separate components here. I'm doing this just so that it's a bit tidy, because I can't graft the output before it goes through the endpoints, or else the shift list won't work properly. So I want to do them both at the same point, so I'm going to do them like this. And so I'm going to plug those into each other, and then as soon as I shift this list forwards or backwards, hold on, it's okay, we've probably got a mismatch in our data structure here. Yeah, so if I just grab a param viewer real quickly and show you both of these, the first one has 4 index numbers and the second one has 5 index numbers. So the way we rectify that is with a simplify node. And so now the data structures should match up. Okay, so now if I select this average point, you can see that as I shift through this list, okay, so that's the default point, halfway between this point and this point, either -1 or +1. Okay, no, +1 doesn't do it. -1 gives us what we want. It'll give us the midpoint in between here and here. Okay, I can get rid of these. And so now all we want to do is we want to create a vector 2 point between each of these points and the plane in the middle. And so once again we're going to have a mismatch of our data structure. If we plug this in here and we grab another one coming out of here, you'll see here we've got 60 branches and here we've got 20 branches. So what we need to do is we need to match up our number of branches, and the way we can do that is we can see that there are 3 branches corresponding to every one of these first index numbers. So I'm going to use what's called a shift paths component to match that up. So it basically eliminates this this second number here. According to this offset. If I set this to -2, it would shift back 2 indices and it would break my data structure. So I can only shift back 1. But that'll be good enough because that'll give us 20 branches that match with our 20 branches. Cool. So now we are going to make a vector from, you know what, we'll go from these outskirt points towards the center. And I'm just going to turn a whole lot of this off. Actually, let me turn these on because these are what we still want. And so I'm going to set an amplitude for each of these vectors. And this amplitude is going to be defined by a range. And the steps for my range is going to come from this expression here. And I'm going to use my favorite component, the graph mapper. So I'm going to plug that in there, and I'm going to try something different this time. I'm going to use a sine curve, because sine curves are pretty cool. Okay, and so we're going to, instead of multiplying the output, we're going to use a remap numbers component. So the remap numbers component asks for 3 things: a value to remap, a source domain, and a target domain. The source domain is already 0 to 1, so we don't need to worry about plugging anything in there. But we are going to construct another domain for our target. And I'm going to drop down 2 sliders here. I'll give them maybe a maximum value of 50. One of them will be negative. And the other one will be positive. And so this is going to be my amplitude by which I move each of these midpoints. Now it looks like we might have a slight issue with the data structure again. We've got 20 trees here, and each of them have 20 points. That's not what we want. So we need to graft what's coming out of our remap, and there we go. That's more of what we want. Cool. So now I'm going to create an arc 3-point. Oops. Arc 3-point. And so this one that I just created is going to be my middle point, and my my other points are going to come from the start over here and the end over here, which was shifted. It's important that you use the ungrafted ones, because that will give us the matching tree structure. Alright, cool. So now we've got the basics of the definition sussed. One other bit of control I want to insert in here is the amount of all this domain factor here. So I'm going to create another range component. It's going to take this value for the number of steps, and I'm going to construct a domain. Okay, and so we'll plug that in here, and it's going to do something a little bit weird at first, and that's just because once again we've got a mismatch in our data structure. So we've got, this is where the the issue is happening. So we've got 20 values coming in here, each on their own separate tree, and then 20 values here, each in a single list. So we're going to graft those, and we should more or less get what we want. Okay, so what I want is basically it's just going to give me a little bit of the curve at first, and then at the very end it's going to give me most of that curve, and then in the middle it'll do, or it'll sort of interpolate between that. And we're also going to mess with our sine function a little bit. You know what, I'm not liking how that's looking at the end. Maybe I'll tweak these numbers a little bit. Okay, there we go, something like that. Now what I'm going to do is I'm going to join these curves up. Okay, so we're going to join these three curves with the curves coming out of this rotation. So I'm going to plug that in here, and we might have a slight issue here. Yeah, it hasn't joined them properly, and once again that's because we've got a mismatching data structure. So this is easily rectified with the simplify tree, as I said before. What I'm going to do is I'm just going to plug that in there. I'm going to disconnect my arc, because this is going to remove, well, this is going to look through our data tree and remove all the similar, all the matching items that it can. So if we've got two different kinds of data trees plugged into here, it's not going to do what it should. These need to be connected into separate nodes. So plug each one into a separate thing, and we should be getting, yep, matching data structure. So now we can turn these off. In fact, we can turn all of this off. And now we can offset these curves. And I'm going to offset them. Let's see, I'll give this a maximum value of 100. And we might have a slight issue here. Yes. Okay, good. I can point this out to you as well. So what sometimes happens with curves is when Grasshopper is evaluating the planarity of the curve, it's not always going to match up with what you expect. So you can see on some of these curves it's offsetting inwards, and some of them it's offsetting outwards. And the way we resolve this is just by plugging all of these planes into our offset as well. And that'll make sure they're all going in the same direction. In this case, they're all going outwards. Cool. So now I'm going to loft these together here, and let's check our data structures might change a little bit. Yes. What I should also point out here is what Grasshopper does is that with a lot of the components that you use, when David Rutten created this system, I guess he thought that he sort of made an exception for how data trees would store index numbers. So you'll see that between these two nodes we get two sort of extra index numbers, and this is just because there are two different ways, there are two different possibilities in this offset node for how you could sort of manipulate the data structure further. So it's always going to add a placeholder into that in case you need that further down the line, in case you do suddenly change from a non-changing index to a changing index. So once again, we're just going to simplify. We can just simplify this in here and in here, and we'll get matching structure. And then we're just going to extrude these, and our extrusion is going to be based on a y vector, and the y distance is going to be a multiplication of, let me just grab a slider, of this distance that we used in our series, which is the distance between consecutive rings. So using this we can control basically how much of that consecutive distance we want it to cover. If we set it to 1, it will cover 30 units. If we set it to 0.5, it will cover 15 units, and we can do anything in between. Cool. So that's the basics of this definition. What we can now do is we could go back and we could make this a little bit wavier. We could add in a whole lot more to the series, so it would kind of give us a much smoother interpolation along this, geez, I don't even know what to call this shape. And we could increase the amount of segments we have, but you know what, I quite liked it at 3. This slider no longer does anything, and we've got control over our our segmentation of this initial arc. And if we wanted, we could change this to a different kind of graph, but you know what, I'm quite happy with that. I'm going to bump this up to 0.9 so that I've got a tiny gap, and I'm going to bake these out to see how they look. And cool, I think that looks pretty sick. Nice little gap between those. We could do a really nice render looking down here with light sort of streaming through. Could be quite cool. Alright, that's been a tutorial, mainly just so that I could explain some of the more sort of technicalities of data structure, and we did it to create this shape. I hope you enjoyed the tutorial.